Hello, and welcome to Drift Creek Camp. I've put together a short film as an overview to help you interpret the different geologic features that can be seen here as you explore the area. As we hike through the loop, we will learn how plate tectonics, volcanoes, weathering, and time can shape an area into what we see today. Long ago, the place where we are standing was far to the east and out on the floor of the Pacific Ocean. The world was a very different place. Oregon was only a slice of the place it is now. Geologists have worked hard to come up with models to help them understand how things came to be and what we might expect in the future. The Earth is always changing, but sometimes the changes are so slow that we can't even see them in our own lifetimes. Other times, the changes are rapid, and landscapes can be changed and altered in the blink of an eye. But to discover the story of Drift Creek, we must understand the bigger picture. Our planet is made up of different layers. It's almost like a giant jawbreaker, except for the whole planet is not solid. It is believed that the center of our Earth is a solid core made out of heavy metals and is under a tremendous amount of pressure. In the outer core is a thick, liquidy consistency. The next layer is called the mantle. It is an extremely dense layer of rock that is so hot that it would be melted if it were not under so much pressure from the weight of the crust of rocks above it. The pressure changes the behavior of the rock, making it like a pliable plastic. It acts somewhat like silly putty. The next layer is called the asthenosphere. It is the part of the mantle that the very last layer floats on. It is also very hot and can flow under pressure. It is also slowly churning because convection currents found in the mantle. The lithosphere is the name for the very outside layer of the Earth. We also refer to it as the crust. The Earth's crust is not one big solid mass like an eggshell, but it is cracked into huge chunks that are called plates. There are two kinds of plate material. The oceanic crust, made from heavier iron-rich basalts. These can be formed as the asthenosphere rises into thin spots made by the spreading of the crust along ocean ridges. The other kind of plates are called continental crusts. They are formed out of lighter weight minerals. So even though the continental crust tends to be much thicker than the oceanic crust, it is still more buoyant than the heavy oceanic crusts. These plates are less dense than the heavy melted mantle rock, and they slowly float on top of the mantle. These plates are being pushed together, pulled apart, slid past one another, and slid over the tops of each other very slowly all over the Earth. They are always being created and destroyed, and we just happen to be living on the edge of a plate boundary where this is happening. We in Oregon are on the edge of a great slow collision between continental crust and oceanic crust. Let's bring it back to Drift Creek Camp. We now know about the different kinds of plates and that they're being pushed and pulled. So let's see what happened here. Once upon a time, the oceanic plate was traveling in a northeast direction, very slowly. Geologists measure this traveling at about the rate a person's fingernail grows. A hot spot in the asthenosphere forced its way up through the seafloor, creating undersea volcanoes. These volcanoes in the ocean erupt differently than the ones on dry land because the lava reacts with the cold seawater and is forced to cool much faster. And this changes the way the basalt looks. And we will see the examples of this in camp. Geologists know that undersea volcanoes erupted many times over a long period of time because there are layers of marine sediment in between the basalt lava flows. It would be like you did not clean your room at all for many years, and all the candy wrappers would be in between layers of dirty laundry and dishes, forming a giant mountain. These volcanic eruptions formed many undersea mountains over time, and eventually the plate moved off that hot spot and the volcanoes stopped growing. Meanwhile, the North American plate moved very slowly westward, and because it was lighter and made out of less dense rocks, it bulldozed right over the top of the oceanic plate. What happens when the plates collide, you ask? In this case, the oceanic plate is forced under the continental plate, plunging it deep into the earth to be mangled and melted and recycled as molten magma in inland volcanoes up on dry land. This is called subduction. Much of the softer marine sedimentary rock, and sometimes even volcanic islands, are scraped off of the oceanic plate and added to the continental crust plate, like a snow plow scraping snow. This is called accretion. It can be a messy process, but our coastal range has many tilted layers of ancient seafloor sedimentary rock that can be seen in the road cuts. Eventually, the edge of the continent slowly lifts like the edge of a teeter-totter, raising the accreted seafloor material as it rides over the top of the oceanic plate. Now, something that was an ancient volcano on the ocean floor is redeposited as a mountain range on the Oregon coast. Geologists call the formation we are on the Siletz River Volcanics. We can go look for examples of the ancient volcanic rocks as they appear today. We will see examples of erosion and of weathering, as this formation remains part of the rock cycle.